B2A Solutions is your trusted IT consulting company located in the heart of Europe. We design, build, and maintain scalable and user-friendly solutions tailored to your needs. Want to join a team that is shaping the future of the JavaScript ecosystem in Belgium? A team involved in the community by organizing events and contributing to open source? Join B2A Solutions now.
Tejas Kumar he must have been some sort of a child prodigy. You were, right? I guessed as much. He's been coding since the age of 9. I was learning how to play the recorder at the age of 9, just to give you an idea. So he's been coding since the age of 9, and public speaking since 2012. So that's 10 years. So I'm kind of managing the expectations of Mr. Kumar as a speaker. No pressure at all, but I'm sure you can take it. He is here. He is the. Oh, you're wearing a stately T-shirt. That's kind of a hang in there, Matt. Exactly. Yes, we're thinking of you. He is the director of developer relations at Xeta. Let's hear it for Tejas Kumar.
Hi. It's so nice. Thank you for the applause and the awesome. Dang, I was about to start dancing. It's good to be here. It's good to feel the energy. This is an amazing conference. I can actually see the back row, and you look good. Let me tell you that. I'm honored to be here. What an intro. I'm a bit scared now. I hope I deliver on these expectations, but it's true. I've been coding since I was actually 8. And speaking for a while. Hope to not talk too much and actually get to some good stuff here today. I have a slide with my name on it, but also a pronunciation for you, Tejas, like advantageous, or I used to, before the apocalypse, I used to say contagious, but anyway. And I'm the director of developer relations at Zada. We are focused on developer experience. We just want to give developers the best possible time and experience with databases. But that's not what we're here to talk about today. Today we're here to talk about the next evolution of data infrastructure for JavaScript developers, because it's BE.js. And you know, JavaScript has been monumental. I think all of you in this room will agree with me that from building front ends to now even the back end with Node.js, JavaScript is kind of everywhere. And oftentimes, we get full stack developers because there's so much overlap. But let me talk to you a minute about the motivation behind this talk. It says I have 4 minutes left. It's awesome. It's awesome when there's a big clock there because I know exactly what to ignore. Anyway, so the motivation behind this talk is, JavaScript is a language where you can write front-end applications, you can write back-end applications, and you get this title of full stack developer. I consider myself a full stack developer, but if you've heard this title a lot, you may have seen the memes. Have you seen a meme around full stack? Yeah, okay, you know what I'm talking about. That's kind of the motivation of this talk. One of my friends, Swix, we spoke at the same conference, and he had a slide about full stack developers. In case you can't see it here, this is like either we're really good at front end and maybe the back end needs some help, or we're really good at back end and then the front end needs as full stack developers, there's usually something missing. And so for our time together today, I want to talk to you about data infrastructure with JavaScript in that space, because the truth of the matter is this. Some of us feel like imposters in the database and data infrastructure space. Some of us JavaScript developers. If you have imposter syndrome, if you've had imposter syndrome and you're comfortable sharing, show me your hand. Let me look at this. Look, everybody in the room, right? So it's common. And my goal here today, the motivation is what? Is to have you leave here with less of that. Is to have you leave here with a sense of you belong in this community and you can stand up in this community and you know your stuff, okay? And so I have maybe 4 slides, and then we're just going to write code and build things together. So we go on a journey and we learn, okay? So motivation of this talk is what? Let's fix this imposter syndrome nonsense. With that, I want to talk to you about data infrastructure specifically. And we'll define what that means, and we'll build it out together. For the purposes of this talk, data infrastructure is everything related to the backend, so the data side of popular web applications. Be it something huge like Instagram. It's flashing now because I have 1 minute left. I'm ignoring it. If it's something super popular like Reddit or Instagram, or even if it's like your weekend project, maybe you want to build a game and have like a leaderboard of scores, right? Everything needs data. Can you imagine Wordle without data? You just have colored squares with no letters, right? So data is important. And for data infrastructure, let me just draw. I would rather not spend time designing slides, but what we'll do is we'll exit out of this and then just draw stuff. So if I pull up my Chrome, this tool is called Excalidraw. It's by Viju, who's a very talented person. So data infrastructure. All of your data infrastructure usually has a database. So we're just going to do database. There's a lot of sometimes decisions to be made of, do we do NoSQL or MySQL or your SQL or our SQL or whatever. For this talk, we'll just call it a database. There's trade-offs, but we'll call it a database. And if you're more of a front-end focused person, you'll usually have like a UI. You'll use maybe React or Svelte or Vue. And you'll have an API layer, and they're connected. So you'll write your UI to talk to your API will query your database somehow. This will work great for a while, but then if you're successful, you'll have a lot of people using your thing. And you'll have what? You'll have load. You'll need to scale. How databases scale usually, at least the relational ones, the easiest way for them to scale is vertically. So you'll add a lot of like disk space, you'll add RAM, you'll add computation, so you'll build beefy machines, supercomputers, if you experience a lot of scale. But these have a ceiling, either in how much power you can put in a machine or how much money you can spend upgrading a machine. And at this point, what do you need? You need to scale horizontally. So you add machines besides this, and you replicate your data across. If that sounds complex, it's because it is. So then you add multiple databases, and you have to now coordinate replication and connections between them. This is not even data infrastructure, right? Because after some point, as you scale, you're going to realize you're going to hit performance bottlenecks. You're going to realize our thing is slow. This design is slow. Why? Because databases usually read from and write to disks. Even if it's a solid-state drive, a disk by design is slower than random access memory, or RAM. So you'll need to store some data in RAM that people are accessing quickly so that you can serve it to them faster. A common tool used for this job is called Redis. Redis is actually a lot more than an in-memory cache, but a lot of people use Redis for in-memory caching. So how this will work is your application will talk to Redis and say, hey, do you have something for me? Redis says no. That's called a cache miss. And then then your application will have to call out to the database, okay, give me this. This is going to be slow the first time, but what you'll do in your application is you'll take that thing from the database and store it in Redis. So next time you need it, it's instant. Okay, this is an I've seen this happen over and over and over. It's like Groundhog Day. Everybody follows this path. Do we stop here? No, because as you grow, as you accumulate a lot of data, if you've used Jira or Confluence or Reddit or Twitter, all of these have tons of data. What else do they have? What do you have when you have tons of data? Search. You need to have a way to search through data. And this is a common use case for some type of search engine. So people tend to use Elasticsearch. We won't get into details. We just say a search engine. But now look, you have this huge stack, and you need some way. So your app will end up querying your search engine, but in this design, your search engine is empty. There's no data there. You'll need to work out some way to replicate a subset or maybe all of your data from your database into your search engine. How? You'll need some type of queuing mechanism. So there's an open source tool called Kafka probably, and your database will use logical replication probably to send its data to Kafka in a structured way. Kafka will save it to your search engine, and that is what we consider data infrastructure for the purpose of this talk. Is that clear? I see you nodding. This is complex. This is complex at any company with any scale. Like if you're a small startup, you would either have to build this and manage it yourself, and you'd have to pay salaries to people to build and manage this. It gets expensive on the hardware costs, on the complex. It's just mentally expensive. It's financially, it's just expensive. But this is where we find ourselves today. For the purpose of this talk, what we're going to do is we're going to talk about data infrastructure then, data infrastructure now, and data infrastructure in the future. So the title of the talk is The Next Evolution of Data Infrastructure for JavaScript Developers. And so we'll use JavaScript to dive into these topics. Let's talk about data infrastructure then, how we used to do things earlier in the JavaScript ecosystem. As I was introduced, I've been doing this for a while. And back in the day, and maybe if you're not careful, even today you'll end up doing something like this, where what we need first is a database. Okay. I'm going to use Docker. How many of you are familiar with Docker just to get a feel? Okay, yeah, everybody, good. I don't need to introduce Docker. So what I'll do is I'll Docker run, and I'll remove this after I run it so I don't keep it in memory or on my system. And I'll add an environment variable called Postgres password. We'll use Postgres. I know some people like to use Mongo. It doesn't really matter. We're just talking about databases. Password is yes. And we'll run Postgres just like this. So it's running, the database system is ready, except it's inaccessible. I have no way of accessing this database. I'm also not forwarding a port from my machine to Postgres. So what I'll do is I'll kill that, and we'll do it again. But I'll forward a port from port 5432 on my machine to 5432 inside the Postgres virtual machine. Okay? Now it's ready to accept connections, and I'm ready to interact with it from my JavaScript application. This is how we used to do things back then. So now, if I open this, I'll open my code editor and start writing some code. So I will create a new file, call it index.ts. I'm using TypeScript. I know this is BE JavaScript, but it's a superset. If you don't like it, I have nothing for you, except maybe some sympathy. I don't know. I'll teach you TypeScript if you need. So what am I doing? I need a server to interact with this database. So I'll import Express from Express. Express I feel like it's the de facto way to build servers in JavaScript. And we'll instantiate an app. So we'll call Express here. And we'll listen. So we'll do app.listen on port 3000. It's the most common port probably for dev servers now. What do we want to do? We want to interact with our database. So I'll listen on a route, app.use. Sometimes TypeScript hurts like that. But anyway, I'll use db. It's just /db. And on this route, I get my request and my response. And I can do stuff. So what do I want to do? I want to connect to the database. I want to query the database. For that, I'll use a node library called PG. It allows you to interact with Postgres databases. I'll need a client, so pg.client. And you usually connect to Postgres via a connection string. Sorry, I need to use new here. So connection string. And the connection string looks like this. You have a protocol. You have your username, which is Postgres. My password is yes, as I decided. At the host name, which is localhost, and a port. Localghost.dev, she's here. Localhost 5432, and then the database name Postgres. So now I have this client instantiated. I need to connect. So I'll await client.connect, like that. I can't do await unless I async. Boom. And now I can run some queries. So let's do that. Client.query. I need to create a table. I'm literally writing SQL. As a JavaScript developer, I usually don't want to do this. But this is how it used to be. Create table if not exists. This is just maybe a table of the cool people I meet at the conference, right? So names. I called my table names. And I have an ID, which is a serial type. It's not null. And it's the primary way I identify stuff. Okay? And then I have just name, which is text. So that's my one query to create the table. And now I'll insert some stuff just for fun. So I'll do another query, and I'll insert into names, name, and I'll do who's a cool person I met here. It's let's see, it's Ujwal. He's over there? What's up? There's also Sophie, who just gave the talk. There's Eleftheria in the audience. Okay, cool. So there's these people I met. There's a lot more. All of you are cool, by the way. We have only 30 minutes, so I'll keep it at 3 for now. So we insert data into this, and now I want to get the data out. So I'll do rows as a destructure, and I'll await a query where I select some rows. So I'll select all the rows from names. Okay. And now I just want to send it back to the web browser that's requesting this. So I'll res.end, and I'll stringify the rows. Logically, this should work. If this doesn't work, I'm not so good at my job, and I'll need you to understand. So let's go here, and we'll ts node index.ts. Okay, no errors. I think the server is listening. If we circle back here, we go to localhost 3000, cannot get slash. That's good. It's /db. Okay, so I've connected to a database. I've created a table, and I'm inserting data and reading it. The problem is this happens on every request, so I'm actually going to just keep inserting stuff here. It's not, the point I'm making is this is how we used to work. We used to instantiate a connection to a database, run queries, and so on in a Node.js backend. In the early Wild West days, kind of where Web3 is today. Am I allowed to say that? Anyway, So this isn't ideal for a number of reasons. Number one, if you look here, I'm doing one connection per request. It's bad because Postgres has like a connection limit of like 500 or something. There's a hard limit. So if you get like 501 users or 501 requests, which you probably will if you're cool, if your app is usable, you're going to have a hard time. It'll actually be inaccessible. How do we fix this? We use a connection pool. A connection pool, for those of you who aren't so familiar, who maybe you have some imposter syndrome around that, a connection pool is kind of like a library, okay? It allows you to borrow a book or a connection, do your queries when you need it, and then you give it back to the pool. And then the database can coordinate different connections based on the pool. So let's use a connection pool here. This library is pretty nice because I can move out of the request into module scope. And instead of pg.client, I do pg.pool. Literally, that's it. I can specify a max number of connections, let's say 100, just for fun. And now if I go restart my server, go back here, the database is available. I still keep inserting stuff. But now I'm talking to a connection pool. That means there will never be more than 100 concurrent connections to the database. If I go over, I can deal with that, but the connection pool is being used. This is already better. So that's how we used to do it back then. And let's revisit the diagram a little bit here with the data infrastructure. So far, we haven't talked about a UI. My assumption is that because it's JavaScript and the most popular runtime of JavaScript is the browser, many of you have built UI things with JavaScript. So we will not cover that because we have 30 minutes, okay? But what we do have is an API using Express. So we have an API. An API is a way to interact with the database. And we have the database as well. It's not distributed, so maybe we can get rid of that. We have the database. The problem I see here is we're managing servers. It's hard. Like if I have 10 months of investment to build a startup, I have to provision this database. I have to think about scale. I have to think about my connection pools. I'm losing time. So if I have like a limited time to build something, I'm spending way too much time on these details. I would like them to go away, okay? What is the evolution of this? How can this get better? There comes a time in the software development or the company development lifecycle where you often have to trade control for convenience. This happens all the time. You sometimes have way too much control, and you need to sometimes give that away for convenience. For example, if you have a self-hosted database server, you have a server right here, you provision it, you connect it, you do all the stuff. You have a ton of control, but you spend way too much time controlling. And you usually want to give that up. Let someone else manage that so you get the convenience of what? Of building your app. So I tell you that because this is what we're about to do. And this kind of leads to where we are today. How about we make the API someone else's problem? Because my API is super rudimentary. I'm like doing a very specific query. I'll need multiple endpoints. I can't even imagine the decision of like REST versus GraphQL. Then you have authentication. Then you have authorization. There's way too many things here. So you know what? I'm going to trade my control of the API for convenience and say, hey, let some other open source project handle it for me. How we'll do that is like this. What I'm going to do is I'm going to kill this database. Goodbye. And I'm going to use another open source project to handle the API for me. I do need to put them, though, on the same network. So what I'll do is I'll create a network. I'll do docker network create Belge. So I have a Belge network. And I'll start that Postgres database again. But I'll put it this time on the Belge network. So I'll do net Belge. Okay. It's coming back up. It's fine. I probably lost all my data because I didn't use a virtual volume. It's fine. So now we'll make the API someone else's problem. We'll do that using an open source project called Hasura. This is not a sales pitch. It's just an open source project. So we'll do docker run. I need to give it, I'll remove the container when it's done, and I'll give it some environment variables. We'll do Hasura, GraphQL, database URL. And this is literally the same as that connection string we have over here. So we'll just copy that. And instead of localhost, though, we're talking to something called PG. PG is the name of this container that's running here, I think. Did I give it a name? I didn't give it a name. That's okay, see? It's a good thing I checked. So we'll do name is PG. Boom. So it's good, it's running. So we'll talk to PG on the same port, whatever, and then we'll also enable the console. So we'll do Hasura, GraphQL, enable console true. Two environment variables. We will map a port 8080, and then we'll run Hasura/GraphQL engine. Open source, you can use it whenever you want. This is running. And so now this thing manages a connection pool to the database. This thing actually talks to the database, interfaces with the database, and what do I get in exchange? I get an API. So if I go to localhost 8080, the site can't be reached because it failed to connect to my database. I love live coding because people do it for me. Thank you. I need to do the Belge network. Who said that? You? Ujwal. I knew he was a cool person. So, thank you. So it's running. It's on the same network. Localhost 8080. Boom. Okay. So it started. I have this console, and this allows me a fully interactive API with my database. So I can go here. I can go to the schema, create a table exactly as I did before. The table is called names, or let's call it people. And we'll have a column ID, which is a auto-incrementing number. Can you go away, marketing thing? Okay. It's unique. That's feedback, Hasura, if you're watching. And we'll do a name, which is just text. So I can nicely visually define. I don't need to write SQL anymore. Primary key is ID, and then boom. I create a table. I can insert rows. So more cool people I met. I have Tally. I have who else? I have exactly Debbie. And say your name. Shout a name. Adam, that's right. Adam, everybody. Let's hear it for Adam. So cool. There's 3 names in my database now. And what I'm going to do is zoom out a bit. And I get this full API with auto-completion. Oh, my Lord. So I can choose these fields. I query it, and I get the data. But how do I fetch this in my app? I can open my network inspector. I get an endpoint here. So I'm going to fetch this, right? It's a post request. I know this because it says post right here. And body is a JSON string of a field query. Oh, shit. I closed this too quickly. Live coding's awesome, no? All right, so I'm going to paste this query in here as a multi-line string. And then what I'm going to do is, after this resolves, serialize it to JSON, which I'm assuming if you've built a UI, you've done quite a bit. And for the purposes of console logging, since we're in the console log the response and see what we get. And as predicted, we get back data. OK, so the API is effectively someone else's problem. What I'm going to do is I'm going to copy this fetch and run it in my Express server over here. And just look, this is my favorite part. I get to delete code. Holy schniznit, right? So what I'm going to do is, bye-bye, Postgres. I don't need to write you anymore. No connection pool. Oh, my God. Let's just get rid of all this trash. Wow, wow, wow. Amazing. And so now I'll just, data is await, and I'll paste that fetch. And then we will remove the console log. And this looks amazing. So now I'll JSON stringify data. OK. I think I'll need to restart that Express server. Oh, it closed itself. Awesome. I also need a way to fetch. Fetch is undefined. So let's do that. We'll import fetch. Because we're not in the browser. Fetch is global in the browser, not yet in Node. This is also why I use TypeScript, because I can do shit like that. OK, so now we will run this, no errors, and go back to our local host. What do we have? Look at that. So how has our data infrastructure evolved? What have we done? We've given up some control. We no longer write the API. We no longer write SQL. We no longer manage a connection pool. We've given up that control, but what have we got? We've got convenience. We've got all kinds of convenience, because it's a convenient way to create databases, to create tables, to query it. And also it's type safe. We get that nice autocomplete UI, the console. We've given away control for convenience. Am I comfortable with this for my company? I am, because it's open source. I can look at the code. I can do whatever. So that is actually where we find ourselves today. This is a lot of companies, successful, profitable companies, build this way today. And I used to work at a company called G2I.co, this company. This is their stack. Like, it's Hasura with Postgres. This is how they run, OK? I know that because I built it. The problem, though, is they're popular. It's a good problem to have. But the problem there is I still need to worry about scale. Because if you look at the terminal here, we're running Postgres, we're running Hasura. These are 2 servers that we are still having to build, maintain, and scale, okay? So if my thing gets slammed now, I'm in trouble. Where do I deploy this? Do I use Amazon Web Services? Do I use Heroku? At this point, I don't know if you can relate, but this is where I develop like analysis paralysis. I'm just like, someone help me. I'll give you money, just do it, make it go away. So this is still a problem, but this is how it's working. People hire smart people, they pay salaries, it's great. This brings us to what we consider, the next evolution of data infrastructure for JavaScript developers. Let's revisit that diagram. So in this diagram, what do we have? So the API is effectively now someone else's problem, right? Hasura controls that. We have a UI in our minds. We're not going into it for the sake of time. But so we have the API handled. Can I change the color to say we have it handled? Let's do pink. OK. We still have to build, scale, and maintain a database. And to some degree, also the API, because it's a server that we control. So it's not fully, let's keep that white. How can we improve this? If we give up a little bit more control of running the API server, we get a lot of convenience. We can do this using something called serverless functions. You may have heard of this, where you export a function. You don't deal with servers like Express, and then someone else imports the function and executes it. Okay? We can do that using another open source project that I really like. It's called Next.js. So I'll do pages/api/db.ts, for example. And I'll copy the code from here. I can just copy paste. So I'll save this as an empty, or I won't, whatever. This is exactly the same code as I had, but instead of, look, I love deleting code. That's amazing. I'll do const handler instead, and really nothing else changes. And I'll export the handler as the default. That's it. That's all I need. And so now if I go kill my server, which, OK, I kill it, I'll do yarn next dev. So the server becomes someone else's problem. I come here and get a 404, but I go to API/DB, and it still works as expected. What have I done? I've given up control for convenience. Someone else is handling the server that runs my request to the database, so it's one less complexity for me to manage, right? And what do I get in return? Global distribution, scalability, all that jazz. Someone else handles it. And it's actually free at this level of scale, which is quite nice. So OK, now the API is proper gone. So I'll do a dash outline. OK, so the API is no longer my problem. The database, though, is still my problem. So I can kill Hasura here. I don't need it anymore. It's dead. So I'm still running a database. And this is where I believe the future of data infrastructure is for web developers, because they're hard. What if we didn't have to do this? What if we give up a little bit of control for the convenience of the database? And not just the database, but if we look at this diagram, the database, the logical replication, the search engine, the memory store, all of that stuff just goes away. And all of it goes away without effort on my side. What if all of this goes away without me leaving Visual Studio Code? Can such a world exist? And that's what I'm trying to do. That's what I'm trying to build, actually. So let me show you how we're thinking this is going to go. It's in the name of giving up control for convenience. Before I do this, though, I want to be really clear with you that this is something I'm building that I like and that I'm excited about. I'm not trying to get you to use it. I actually don't care if you leave here and never use it ever in your life. The goal is education. I want us to learn together and eliminate that imposter syndrome. Is that clear? OK? What I'm about to show you is experimental. There's people literally deploying to production as I speak, probably. It may break, it may not, but that adds to the excitement. OK? So let's get into it. So how do I move my names database from something I host to someone else's problem and get a search engine and analytics and all that for free? I'm in Visual Studio Code, and my function's working, but I have a cute little butterfly here. Wow, that's amazing. What is that? So I open this, and I'm just going to create a place where I can interact with databases. I'll call it BEJS. It's in my new team. You're all my new team. Hello. I'm going to make a database in here. I'll call it people. What color do I want? I think orange is suitable. Given this vibe, I dig it. So we'll do orange. And so now I have an orange database called people. I'm going to add a table, names, and right in this names table, I'll add a column. Do I need a column? Yeah, it's a string column, and that's just name. Okay. This looks good to me. I want to insert data into this, so I'm just going to insert a record. And what I'll do is auto-completion, boom, name. More names. MC, what is your name? That's short and sweet. I dig it. OK. So CLO, you're officially on my list. Shout out a name, somebody. Alice? Cool. I hope I spelled this right. And I need one more. I'm doing 3 names per database. Norm? It's very normal. Anyway, Norm, cool. So I've got 3 names. Do I, though? How do I see this? I'm just going to click the I. Show me my names. That looks awesome. I dig it. I can actually open this in a web UI if I want to like do something like filter and sort as well. I might sort this alphabetically just for fun. All right, I have data. It's in my database, whatever. I'm going to query this now so I can copy this code snippet and go back to the editor. I could also not open the web UI. I just wanted to flex a bit. And so can you go away? Thank you. So now we have this code snippet. I'm not, kind of like we console logged earlier, I'm not going to console log it, but I'll just await. So I'll do const records. I'll await fetch. Looks good. I'm happy with this. I don't even know what's happening there, to be fair. I'm just going to, and then we'll console log our records that we get. Okay. Localhost, same endpoint, 404. Why? It's /API/DB, right? Okay, so now I have my records and IDs as well. So the data is somewhere else, someone else's problem. I can actually go here as well and kill my Postgres, this thing, goodbye. And so I've effectively removed these problems from my side. I could, if I wanted to. I really hope this works. I don't know, to be honest, but let's do something like nuts. If you see what I'm doing here, just, why not? We'll try and simulate some scale. Does it work? Now is when I get nervous during the live. I really didn't even plan to do this. It may not work. We shall see. Actually, this may not be a good idea because I should probably let I above, and I keep redeclaring I. So you have to add some spice to these things once in a while. No? Okay. Whatever, it's fine. Yeah, I tried, I failed, maybe. Okay, it still works. So that is the evolution we're talking about, where you give up even more control for the convenience. The convenience of being able to create and query things like from here. I didn't actually have to leave. I have my database. I could even add another one if I want. I could, because of the level of abstraction here, I could branch this database like a Git repo, make changes that are destructive, A/B test, whatever I want. But let's go back to this diagram now and look at how things have evolved over time. So the API has already been abstracted to serverless functions. This, and this have also been abstracted away for the purposes of actually me building my company, building my product. As I said earlier, if I've received some investment, I have like runway of maybe 10 months, I would be very sad or scared if I spend 4 of them focusing on databases, on scale, on APIs, and so on, especially if it's an app like Twitter, where I just want people to send a tweet. So all of these are handled for me, and I think this is exactly the next evolution of JavaScript data infrastructure, is we're moving from managing servers ourselves to a word that people are very polarized by. What's the word? The word is serverless. We're giving away, serverless is essentially when you give away your servers and let someone else manage it, right? So it's serverless for you. And if you look here, everything here is managed, actually including the UI's deployment. You'd probably use a platform like Vercel or Netlify. Debbie was wearing a Netlify shirt, exactly. So you'd even deploy your site somewhere else and let other people handle it for you. What is the point of this, though? The point is to allow you to build your thing, right? Let's talk takeaways, and then we'll wrap up. There was a demo slide, which is what you saw. This is my second to last slide. I love this presentation. There's like almost no slides. Takeaways. What do I want you to leave here with that will help you in your career and that might help you, build the best JavaScript projects you've ever built in your entire life? Number 1, why not both? So, like in the database space, there's a lot of like MySQL or NoSQL or SQL. Like there's a lot of this or that, and the JavaScript community is notorious for it. We were having dinner last night with Debbie, and we were talking about how like there's usually a war in JavaScript. Like there was the browser wars. Do you remember those? Like, oh, I'm an IE person, I'm a Safari person. Thanks to web standards, we don't have that anymore. Probably. We then had the framework wars or the UI library wars, Angular versus React versus Vue. I think we coexist a bit more peacefully now. But there's like Next.js versus Remake. Why not both? Look, there's different tools with different use cases, and you can benefit from them. In fact, I used to work at Spotify, and as a big company, we were often starting new projects internally and so on. We had SQL, and we had NoSQL. It's fine. You probably still listen to Spotify. Okay? So why not both is a great question, and I want to encourage you ask this because you'll benefit. Number 2 is think about abstraction. Abstraction can be amazing, but it can also be dangerous. Abstraction is when you give away control for convenience, as we've been talking about throughout this whole talk. For example, I think React does a fantastic job of abstracting away just enough of the document object model, the DOM, so that you can manage your state in a comfortable way. But you do give up more direct access to your browser, right? So abstraction can help or hurt. Maybe you need a very low level of abstraction where you have a physical database, you're managing it yourself, and it's amazing because you can handle like security. You can do like all the bespoke security stuff you want, but you don't have as much control. That's fine. Or you maybe want something super high level of abstraction where you don't have as much control, but it's a solved problem. So I'd invite you. I'm speaking faster than my mouth. Let's slow this shit down. You know what I'm saying? I'd invite you to consider what level of abstraction you're going for. Okay. And number 3 is trade-offs. Everything has trade-offs, and trade-offs are good. If, for example, you decide to go with like a NoSQL database, like something like a document store like Mongo, the trade-off is your consistency of your data that you get is going to be eventual. It's not going to be like immediate. That's just a trade-off. Maybe you need it. Maybe you just need like a like button. Nobody cares if a tweet has like 1.3K likes or 1.4. Then it's popular. So eventual consistency and a NoSQL model is great there. But maybe you're building a banking app and you need immediate consistency. People need to know at this point in time, I have this many dollars. 0. But like you maybe need to know that immediately. So then maybe go for a more immediate consistency ACID-based database model. Both are good, but I'd invite you to consider the trade-offs and weigh them against the scales. Okay? And with that, I think these things should set you up for success and remove your imposter syndrome when you're thinking about data infrastructure in JavaScript. Hey, I want to thank you so much for having me and for the opportunity to chat with you today. Appreciate it. Thank you so much.
B2A Solutions is your trusted IT consulting company located in the heart of Europe. We design, build, and maintain scalable and user-friendly solutions tailored to your needs. Want to join a team that is shaping the future of the JavaScript ecosystem in Belgium? A team involved in the community by organizing events and contributing to open source? Join B2A Solutions now.